Hello students, today I plan to do ray optics plus 2 CBSE. The topic is real and apparent depth. We should know the difference between the real and apparent depth. Okay, and if you, for example, if you take a water tank, so let me take a water tank, and if you see it from the top, the water tank, we cannot see the real depth of the water tank. We will see somewhere else at a certain height. For example, if I take an object here, put a coin here under the water, okay, and I'm seeing it from here. I cannot see this coin at this point. The coin seems to be raised at certain distance. It seems to be like it is here, but it is not really here. It is actually at the bottom. Looks like it is here. Okay, so that's because of refraction only. Okay, so this is the object for me, and the ray will start from here. For example, if I have a ray that starts from here going straight, it will go straight without any deviation, go straight. But the ray which goes in this direction will definitely refract. Okay, it will refract, it will move away from the normal. So if I draw a normal here, this ray is moving away from the normal because of refraction. So I'm seeing it from here. I'm seeing it from here. I cannot see this coin. Okay, I cannot see this real object. I can only see the image of this object. So this is the object O. I cannot see the real object. I can see only, if I extend this line, I can see only here. Sorry, I can see only I can see here only. This is the point. I just extended this line and then meeting this straight line, because this is also one ray. So this is where the image will be formed. This is the image, and I can see the image of this object at this point, and it looks like the object is actually here and not here. Okay, and for example, if this ray is O, A, and I'm taking this ray is going like this. This point is A dash. Okay, and then this point, let me take this B, this is C. Okay, so and this is the incident ray. So this angle is angle of incidence, and this is the refracted ray. From the refracted ray to the normal is the angle of refraction. So you have to take a normal. From the normal to the refracted ray is angle of refraction. This is angle of incidence. If this is I, this opposite angle is also I. Similarly, if this is R, this opposite angle is also R. Okay, and then I want to find the apparent depth. What is that apparent depth? See, from here, from the surface of the water till this point where the real object is present, this depth is called as real depth. But image is formed only here. This is the virtual image. So this height from the surface is called as the apparent depth. This is what I want to find. I want to find a formula for finding the apparent depth. Okay, so from this diagram I can tell you certain things. This O is the object for me, and this ray A dash is going undeviatedly, correct? And then the ray OB is deviated along BC, okay? And I produce this BC towards I, okay? So when BC is produced back, okay, it meets OA, it meets OA, sorry, OA at I. So I is the virtual image for me, virtual image of object O, okay. So I plan to find only this apparent depth, that is I want to find AI, this is the apparent depth, this AO is the real depth, and this A and B are very close to each other. So B is close to each other, close to A actually. Therefore, therefore I can since B is very close to A, here B is very close to A. This OB and OA are almost equal. Okay, so this OB is almost equal to OA. Similarly, this BI and EI are also almost same. That is IB is approximately equal to IA. So now let's use our Snell's law. So we already know that okay, we already know this is water. Therefore, refractive index of water is mu W. Refractive index of air is taken as mu A. Okay, and then from Snell's law, refractive index of the second medium to that of refractive index of the first medium. This is my second medium. Air is the second medium because ray is emerging from here. Water is the first medium. So refractive index of the second medium to that of the refractive index of the first medium is equal to, formula is sin I by sin R. This is the formula. I want to find sin I and sin R, so I take two triangles. Let me take triangle AOB and AIB. So in triangles AOB and AIB, I can find sin R and sin I and sin R. What is sin I in AOB? Opposite by, so this is my AOB, opposite by hypotenuse. So hypotenuse side is this side, that is OB. This is OB, and this sin R is found in this triangle, that is AIB. This AIB, this angle is R, opposite by this hypotenuse. So AB by IB. So this is AB by IB. It's AB by IB. So now I can substitute the formula here. Let me first reverse this, write the inverse of this. So mu W by mu A, I'm just inversing this. I will get sin R by sin I. Now we substitute the values here. Okay, so I will get uh, let me take some other color. I'll take this color. So now this mu w by mu a can be represented as mu of refractive index of water with respect to air, which is equal to sine r is AB by IB, and then similarly divided by this. This is sine I. This is not sine R. So this is sine I. So substituting for sine I is AB by OB. So this is AB by OB. This EAB and this AB are cancelled. So you will get OB by IB. Okay, you will get this. So therefore I'm just writing it here. Mu of WA is nothing but OB. Okay, I already told you this OB is approximately equal to OA. So I substitute for OB, I'm substituting OA divided by. Similarly for IB I can substitute IA. So here I write IA. So mu of AW is equal to what is OA? And we already know that OA or AO is the real depth. So I get in the numerator I will get real depth divided by what is IEA. IEA is the apparent depth. Okay, so this is what I want to find. IEA is the this side. This is the apparent depth because image is I'm seeing the image only here. So this is the apparent depth. So this is the formula to find the apparent depth because refractive index is already known for water. Okay, if I take water, the refractive index is very simple. Refractive index is already known. So refractive index of water with respect to air is a constant value. It is 4 by 3. So when you substitute this, 4 by 3 is equal to real depth by apparent depth. So I want apparent depth, which is 3 by 4 times real depth for this water air interface. So this is the combination of water, correct? This is water and this is air. So it is water air interface. They have the combination of water and air. The apparent depth will be 3 by 4 times the real depth. Real depth can be measured here, and if you substitute that real depth here, you will get the apparent depth. So I hope you understand this. This is very simple but very important. So if you properly write notes and then if you study, you definitely can write it in exam. Very important. Okay, we will see you in the next video. Thank you so much for watching.